Hello grade 10s and welcome to mathematics. Today we're going to be talking about exponents. Now one of the things I love about exponents is it really shows amateur mathematicians like yourselves how mathematicians like to take really complicated things and make them look really simple. Actually, that's what mathematics is all about. It's about taking things that look ugly and making them look good. Let me show you an example. So over here we have 2 times 2 times 2 times 2 times 2 times 2, and if we were to count them all up, we would find out that we had 22 2's multiplied by each other. Now this is called expanded form, or expanded notation. Excuse the stumble. Yes, and we'll pretend we can spell that. And it comes to 2 to the power of 22. So exponents is a way of writing repeated multiplication without taking up the whole page. Imagine if you had 2 to the power of 100. You would be multiplying 100 2's by each other. I don't have a piece of paper that is that long. So mathematicians write it as 2 to the power of 100. So mathematics is the art of taking something that is complicated and making it simple. And as long as you remember that in every single question that you do, you will be doing far better in the subject. Now let's take a look at the next slide. Over here, I have some terminology. I have the word power, base, index, and exponent. Now I want you to take a minute and just talk with your classmates about what these different words mean to you. Now, you may have the mathematical definition, but don't limit yourself to it. If you want to define a base by something else in the world, then do that. But talk about it for a while. What is a power? What is a base? What is an index? What is an exponent? And we'll talk again in a minute. Now, I hope that some of you were speaking about superpowers. If I had a secret superpower, it would probably be the ability to move things with my mind, especially when it comes to cleaning the house. But that's not really what we're talking about here, is it? We're talking about mathematics and what is a power in mathematics. So let's take a look at this over here, which is 8 to the power of 2. Now, you'll notice that I've said 8 to the power of 2, even though the whole thing is actually called a power. Okay, and this can be confusing because in some textbooks they refer to just the exponent as a power, some textbooks they refer to the whole thing as a power, and it really does get a little muddled. But you don't need to really worry about that. You just need to know that when someone is talking about a power, they're usually talking about a base with an exponent. So let's identify the base and the exponent now. The 8 is the base. And I'm sure when some of you were talking about bases, you were talking about ground level and things like that, because that's what a base is. It's the bottom. And the 2 is the exponent. I'm not going to write out the whole word, because then we'll be wasting each other's time. Now, an exponent can also be called a power or an index, and we sometimes refer to this section as indices. So all of those different words are used to classify this section. Okay, the next bit of terminology I want you to go through. I don't want you to talk about the meanings of the words because it's a little bit difficult to define the words. It's far easier to actually just find an example of the words and write them down. I'm sure by now you are dying of curiosity to see what we're going to talk about. So we'll go to the next slide. And the terminology is, or are, expanded notation, and we have spoken about that already, expression, equation, factorizing, prime factorization. Now, all of these will come into this section. So it's important that we know what every single word is. I'm going to give you 3 minutes now to write down an example of every single one of those words. Enjoy. So how did you do? Shall we check what kind of examples you came up with? I'm going to go to the next slide where I've got more space to write, and I'll write down my own examples. Now, expanded notation is just when we write something from exponential notation into what it really is. It's repeated multiplication. So 2 to the power of 3 is equals to 2 times 2 times 2. An expression is anything that we can simplify. It doesn't have an equal sign in it. So you're just going to simplify it. This question I've just made up, 2x over xy. We can cancel x with x, and we're left with 2 over y. So we've simplified the expression, but we weren't able to solve for any variable. An equation is anything that you are able to solve. So in grade 8, you would have had 2x is equals to 6, and then you would have found that therefore x is equals to 3. And the way you would have got that is you would have divided both sides by 2 to get an answer of x on the left and 3 on the right. Okay, then the next one we need to talk about a little bit. Now, factorization will come into everything you do, so it's really important that you remember all of the different things you can do in factorizing. And I'm not going to write them down because it's going to take too long. So remember, always look for a common factor. And remember that grouping is part of that process of looking for a common factor, as well as changing the sign. Now, these things come into the section of exponents. So it's going to be interesting for you applying them in a new section. Now, on top of all of those common factor elements, you've got a difference of two squares, and you have trinomials, and you have the sum and the difference of two cubes. All of these you should have already done in class. So I hope you put those down in a list underneath factorization. And the last one, the last term that we need to speak about is prime factorization. And that's when we take a number like 29. Oh, 29 is a bad example. Let's take a number 18. And 18, if we write it as its prime factors, is going to be 2 times by 3 times by 3. In other words, 2 times by 3 squared. Now, there is a fantastic button on your calculator that does this for you. And if you haven't found the time to find it yet, look out for it. It says FACT on the top, fact, as in factorize. Now, before we go to the break, we just need to quickly revise our identities and our laws of exponents. Now, all of these, except for one, you have seen since grade 8, so none of it should come as new. Let's take a look. Now, the exponential identities, the first one we've gone over quite a bit already, and that is x to the power of n is going to be x times x times x n times. And x, in order for that to be real, x needs to be a real number. In other words, it must exist, it can't be imaginary, and n must be a natural number. And a natural number is any whole number that's above 0, so more than 0. Okay, then the next one I get asked about often. X to the power of 0 is equals to 1. And people often say, how is x to the power of 0 equal to 1? Well, let's start this off by saying 3 to the power of 0. If you put 3 to the power of 0 into your calculator, you should get an answer of 1. Now, I'm sure we can all agree that 3 to the power of 1 minus 1 is the same as 3 to the power of 0. Can't we? Makes sense. Now, we've got a negative exponent over here, and our next identity is going to tell us what to do with that, but I'll just preempt that, and I'll move that negative exponent to the bottom. So 3 to the power of 1 divided by 3 to the power of 1 gives us 1, because any number that is divided by itself will have an answer of 1. Now, we've just spoken about the negative exponents, and for some reason, people get confused because they look at the negatives and then suddenly they want to work with fractions and all sorts of things. And as soon as fractions get involved, people have little panic attacks. Fractions are nothing to be scared of. They're just numbers. That's all they are. They're not going to bite you. When you have a base with a negative exponent, it's just telling you it's in the wrong position. So it might be in the numerator with a negative exponent, but then it needs to be moved down to the denominator with the positive exponent. And that's a very basic way of explaining it, and it's not very mathematical the way I've explained it, but it does help you to remember how to do it. So when we look at the identities over here, we have x to the power of negative n over 1 is equals to 1 over x to the power of positive n. And 1 over x to the power of negative n is equals to x to the power of n. Now I'm just going to go over one thing over here. If I had 9x to the power of negative 2, the only base that has a power of negative 2 is the x. So that is the only thing that's going to move position. That means our 9 stays in our numerator and our denominator is x to the power of 2. Okay, now let's look at those exponential laws. Remember, we're always looking for bases that are the same value. So yes, it looks like a whole lot of x's and n's and m's in these laws, but try and replace the x in your mind with a familiar number. I like to replace it with 3 in my head because it just makes me feel better, and maths is all about making you feel good. Okay, so the laws of exponents. When we have two bases that are the same, over here it's an x, and they are being multiplied by each other, we can then add the exponents. And a quick example of this is 3 to the power of 2 times by 3 to the power of 4 will equal 3 to the power of 6. And just to prove it does work, that's 3 times by 3 and 3 times by 3 times by 3 times by 3. How many 3's do we have there? 1, 2, 3, 4, 5, 6. So that is 3 to the power of 6. Okay, then if we have x and x as our bases, two bases that are the same, and we're dividing them, we then subtract the exponents. If we have an exponent outside of the brackets, we need to raise all of the exponents inside of the brackets by it. So I've now rewritten this law with x to the power of 1 and y to the power of 1, just to illustrate that the m needs to multiply both by that one and this one over here. Whenever a number or a variable does not have an exponent, it's not because it's not there. It's because mathematicians are lazy. We don't want to write things that we don't have to. So we just expect everyone to remember that if there is no exponent, it automatically has an exponent of 1. Okay, we're almost done here. We have in the brackets, which is pretty much exactly the same concept as what's going over here. Every exponent that's inside the bracket gets multiplied by the exponent outside of the bracket, and we call this raising the power. And once again, we have another law that's pretty much the same thing, just written in a slightly different way. This one, however, is the new bit. And while we go to break just now, I want you to fiddle around with it. I'm going to write something on the board, and then I'm going to tell you to work it out with your calculator. So everyone knows that the square root of 9 is equals to 3. Now I want you to tell me, oh, I made a mistake there. Let's get rid of that. I want you to tell me 9 to the power of what? What goes into that block will give me the answer of 3. So go ahead, take a breather, and when we come back, we'll discuss your results.